upstream practice and preventative controls course tailored for maple producers. We are very excited to see that. Additionally, she has collaborated on research projects aimed at assessing the quality of sap and syrup, assessing defoamer quantity in maple syrups, which you'll be hearing about in a moment, and developing sanitation protocols for maple sugar houses. Her contributions to the food and agriculture community include 1 patent, 13 peer-reviewed publications, and 15 extension publications. And Dr. Nathalie Martin holds a PhD in food science and technology from the University of Laval. Since 1999, she has been a scientific researcher at Centre Acer since 2001 and is a member of the Ordre des chimistes du Québec. She is responsible for the Maple Chemistry Division, which encompasses research projects on the processing and quality of maple products. The current work, led by Dr. Martin, primarily aims to better understand the impact of processes from harvesting to processing on the composition, physiochemical, nutritional, and sensory properties of maple products. And I will turn it over to you to begin. And thank you so much. I'm really looking forward to this presentation.
Thank you so much, Abby. So I will go ahead and start. Natalie, if you don't mind sharing the slides.
I'm coming in. Just a minute.
Oh, okay.
Do you see the slides?
We see the.
Okay, it's not the first one. Yeah, there you go.
Yeah. Okay.
No,
So
it's not the one. Just a minute. Sorry about that.
That's fine.
Okay. There we go.
Oh, that's perfect. Okay. Hello, everyone. So as Abby said, my name is Catherine. I am at Cornell University, and this project was a combined effort with Centre Acer, University of Maine, University of Vermont, and Cornell, and it was funded by NAMSC. It's been a 2-year project, and this is part of a research update from the first year of work. Oh, next slide, please. So to start, I'm going to do a little bit of background information just to cover what really we're talking about, where we're coming from, and what questions we have. And then Natalie is going to take over and describe what we've found so far and where we're going. So first of all, anti-foam agents, also called defoaming agents, their main purpose is to reduce foaming during maple syrup production. And there are multiple different types. You have your common conventional defoamers, such as Atmos 300K. You have Aldo HMS. And then you also have organic defoamers. So this can range from a variety of different vegetable oils. And there are also commercial organic defoamers, such as Transo 580. That's been a popular one for many years. Just a note, in case you haven't heard, the Transo 580 is no longer approved for use as an organic defoamer. However, there are other organic defoamers out there that you can use in place of it. Next slide, please. So now I'll cover the US regulations, and then we'll cover some of the Canadian regulations as well, just still more background information. So what's important to know is that in the United States, defoamers are defined as secondary direct food additives and processing aids. So sorry for the legal jargon, but this is the way that it's presented by the FDA. So this is the kind of language that we need to be familiar with. So a secondary food additive and processing aid in the US, they're defined as substances that are added to food, then have a technical or a functional effect. So they make some type of an effect on that food product, like reducing foam. And they are present in the finished food at insignificant levels, and they do not have any technical or functional effect in that food. So we don't really have a definition for what insignificant levels is. We just have that term. And we don't have a lot of information on what the technical or functional effect is in food after the syrup has been produced. So if you've ended up using too much defoamer at times, then you might get a mouthfeel from the defoamer, that's something that can have the technical or functional effect that we don't want. So defoamers are allowed for use in processing of foods if they meet one of two criteria. They either have to be recognized as GRAS, which is generally recognized as safe by qualified experts, or they must be listed as defoaming agents in the regulations. For the most part, our defoaming agents that are used they contain compounds that are considered GRAS, and that's how they're able to be used. The next slide, please. One thing that gets a little bit confusing in the maple syrup industry is when we look at what the standard of identity is for maple syrup. So first of all, the standard of identity is going to tell us what can maple syrup be. So if you think back to whenever there was a time where these regulations didn't exist, unfortunately, things like flour were contaminated with chalk, and they could be sold that way because there was no standard of identity. They were an adulterated product, and there wasn't a clear definition of what that product was. So the FDA has defined standards of identity for multiple food products, including maple syrup. So what they've defined it as is that the maple syrup must come from an acer tree. It must be at minimum 66 bricks, and it can contain a couple ingredients, and those ingredients are salt, chemical preservatives, and defoaming agents. Now, there has been discussion about the part B, where it says the optional ingredients and that it contains defoaming agents, because it's been a little bit confusing on whether those defoaming agents need to be listed on the label or not. But I have good news. Can you click the next button, I think twice? So in part D of this standard of identity for maple syrup, we have information about what needs to be declared on the label. And so what it says is that each of these ingredients that's used in food shall be declared on the label as required by this section, Part 101 and Part 130. When you dive into what Part 101 says, it says that processing aids are exempt from labeling. So all of this on this slide is really just to say that even though in Part B it says defoaming agents, our defoaming agents are exempt from being labeled as an ingredient on our labels of our syrup bottles. Can we go to the next slide? All right, so we'll jump into the Canadian regulations before I tie the two of these, before I tie this information together. So in Canada, it's very similar to in the US. The defoaming agents are considered processing aids. And so they have a similar definition as we do. I'll just read the parts in red. It's substances that do not have an effect on the intrinsic or internal characteristics of the food, and there are no or negligible residues. So similar to in the US, we don't have a definition for those no or negligible residues. We don't know what that limit is. In Canada, defoamers are allowed for use in processing foods without any inspection, only if the use of these processing aids are controlled by this 4-1 Food and Drugs Act. And next slide, please. And just for those who are listening to this, who are following Canadian regulations, what that means is really you're following good manufacturing practices. You're not adulterating your food. So you can't sell food that has in or on it any poisonous or harmful substance, if it's unfit for human consumption, if it's had anything decomposing on it, if you have mold, for instance. So these are the main definitions of how the food is characterized in Canada. So I just wanted to throw that in there because it is part of the regulation, so you're aware of it. Next slide, please. So what is the issue? So if there is defoamer, we use defoamer, right? We need to use it in the beginning, middle, and end of the season. It's part of our production, whether you're at the hobby level or whether you're at commercial scale. So what if there is defoamer remaining in the maple syrup. We know that in the U.S., the presence is at in the US, the present it should be at insignificant levels, but we need a definition of what that is. And in Canada, those defoamers, if they are present above these no or negligible levels, then they'd actually need to be regulated as food additives. And unfortunately, with that, they would need to be listed as ingredients on the syrup bottle. So what's been done is a petition was sent to the FDA and to Health Canada to help modernize this definition. And the way that we're doing that is that a proposed standard of identity is being established. And so that would be recognized across the world, not just in the US or Canada, but throughout the world. And that would make trade a little bit easier as well. Can we go to the next slide? So a little bit about defoamers. We have a bit of information, mainly from research that Natalie has done, also research that Abby has done, and a paper back from 1969. So we have some information on defoamers that's really helpful, but there's not enough, right? There's never enough information for us to be able to answer every question that we have. But I want to give you an idea of what we do have. So each of these, first of all, in the top of the slide, you'll see the 3 papers in case you want to look them up and read them. And then in the bottom of the slide, I have bullet points on just things to be aware of. So first of all, chemical defoamers are inexpensive and have a lasting effect. There are multiple different types of, or multiple different methods that you can use to reduce foaming in a product, but chemical defoamers are an ideal method for the maple industry just because of lack of cost or reduced costs and their lasting effectiveness. And not all defoamers are created equal. That's something really important to know. You can't just use any defoamer. A defoamer that's used in the milk industry won't necessarily work in the maple industry because they're targeting different things and they work in different ways. Well, not necessarily different ways, but they're targeting different things. So they're formulated for specific food products. And this can include things like how thick that product is, what the pH of that product is, the temperature at which you're using the defoamer, and then also the operation conditions. All of these things should be considered when a defoamer is chosen. So at this point, 24 defoamers have been evaluated, and this was in the 3 studies that were mentioned previously. And a couple things that we found, or well, that the researchers found from the studies, is that vegetable oils and conventional defoamers are relatively stable. They can oxidize, some particularly vegetable oils, and they can develop off flavors during storage. A study from 1969 looked at corn oil, and they found that there were actually byproducts of that corn oil that were found in the maple syrup. And then 3 other things just to be aware of, and part of this I imagine that you all are already familiar with, and that's that maple syrup foaming is attributed to organic compounds such as amino acids. We know that there's more foaming in the end of the season compared to the beginning of the season. We also have more amino acids, more organic compounds at the end of the season. And then a high boiling rate increases the foaming rate. So I know that at my operation, we like to boil on high fire, as they call it. I don't know if that's the common term in the industry, but that's what we call it. So they like to boil on high fire at times. And yeah, we end up getting more foam during that time. So we end up having to use more defoamer. Can we go to the next slide, please? So that leads us to what questions still need to be answered. So we want to know if there is defoamer in the finished maple syrup. And if so, which defoamers and how much of each of those defoamers, and also what form are they in. And we also want to know, will the defoamer impact flavor and syrup quality? And if so, what's that limit? So defoamers should not alter the nature of the finished product. And excuse me. And unfortunately, until we have more data, the quantities used and the residue about the quantities used in the residues that they leave in syrup we're not able to really provide as much guidance as we'd like to. So with that, I'm going to turn it over to Natalie, and she'll be able to share some of the results that we have from this research project.
Thanks, Catherine. As you will quickly notice, English is not my first language, so I'll do my best to make it clear. But Catherine will be there to help me if there's any question about the presentation. So I'm glad to be here to present to you the objectives that we are following to answer those questions. We are actually conducting research projects that is structured in 3 phases. The phase 1 is to develop an analytical method to detect defoamer residue, because there's nothing actually in maple syrup to detect defoamer residue. So we have to develop the method first. And then we have to evaluate the residue concentration in maple syrup in Canada, but also in United States. So this is phase 2 and phase 3 separately. And today we will present some results from phase 3. So the residue concentration in the United States. So in this project, of course, we will do sampling and analysis, of course. We will, with the method, we will analyze the defoamer residues on all the samples that we will gather from all locations. And the samples will be analyzed in Santeracer's lab, and all with the same method. And of course, the results will be analyzed with a focus on out-of-range data. And of course, they need to be discussed with the industry representatives before being used for regulation purposes. So that's the first steps that we will go in before first. So what do we want to do with that project? What do we want to have? We want to gather valid data on defoamer residue in maple syrup. We also want to have a portrait of defoamer residue in commercial maple syrup. You'll see the difference between field monitoring and commercial monitoring later on. We want to have a standard method for defoamer residue, and that method will be available to the industry. We also hope to have data on the best way to use defoamers and on what to avoid. And also we want to have valued data to have a good follow-up on SOE with regulation authorities. And of course, ultimately, we want to achieve the recognition of maple syrup by the Codex Alimentarius with a definition of standard of identity of maple syrup, internationally well renowned. Of course, we can't do all that work without our sponsors and collaborators. You see them all in the slides. We have funding from Quebec government, but also from IMSI, NAMS, and PPAQ, which is Producteurs et Productrices Acéricoles du Québec. It's the Maple Syrup Producers Association in Quebec. So let's get deeper into the results from phase 3, which is the overview of U.S. production field monitoring. Our research team, like Catherine said, is our team is made from several research scientists from different universities. Catherine, Jason from University of Maine, Tim and Mark from University of Vermont, and Catherine, of course, from Cornell University, and myself and my colleague Mustafa from Santeracer. Mustafa is the lead scientist in the development of the method to analyze the defoamer residue. And of course, I want to thank NAMS for their financial support for our project. But first, why do we want to control foaming? Of course, because we want to produce a high quality product. We want to control foaming because we want to have a more uniform processing, a more uniform process, because foam is altering the process. So it's that have an impact on the quality of the product. We also want to maintain a good evaporation efficiency. Foam acts as a barrier to evaporation, which slows the process. So that's another reason why we want to control foaming. Of course, we want to prevent overflows. You probably all know what I mean by overflows. Overflows result in product loss and significant cleaning costs, of course. But also, we also want to prevent hazard for the operators. That's why we want to control foaming. But what causes the foam to form? Of course, sap is changing throughout the season, as you know that. And the changes in sap concentration and composition is because the metabolism of the trees is changing, but also because of the sap contamination with microorganisms. Those factors influence sap composition, and at the end of the season, like Catherine said earlier, we end up with more amino acids, proteins, and polysaccharides in the sap, which cause more foaming. Those molecules are tensioactive, which means that they really like to be at the surface of the bubble and stabilize the bubble and the foam. So that's why at the end of the season, foaming is more important, and the foam is more stable. And of course, because of the heating treatment, this is more important. The heat intensity is important. The higher the heat intensity is, the more important foaming you can observe. There is some best practices to reduce foaming that we already know. First, of course, like I said, you have to control contamination and degradation of sap. That's the first objective. But to do it, you have to sanitize carefully all the surfaces in contact with sap to try to control microorganisms from being in contact with the saps. But also you have to process the sap as quickly as possible and to keep the sap as cold as possible to avoid degradation. You can also control foaming by controlling evaporation parameters. By reducing the heat, you can control foaming. But of course, sometimes foaming is unavoidable. So that's why you have to use foam control agents. You should use products that are easy to use, fast acting, and at low cost, of course. But they need to be food grade and non-allergic. And they have to be used for their intended purposes. The more important thing is to use those products in minimal quantities and only when needed. And why is that? Because the product is labeled as 100% pure, and we want to respect that. That's why we need to have defoaming agent at traces amount only. But the remaining questions are for everyone is what can we use? When should we use it? And how? And is there any residues in our finished product? Those are all the questions that we want to have answers. So the project goal and objective are, the goal is to assess the concentration of defoamer residue in maple syrup produced in the 3 of the leading syrup producing states in the United States, which are Maine, New York, and Vermont. And to do so, we had to identify the most commonly used defoamers. And secondly, we had to document defoamer use among maple producers who follow good manufacturing practices. You'll say to me, what are the good manufacturing practices? But for this project, we had to choose producers that were using the defoamers in only when needed and only in a small quantity as possible. That was our parameters to choose the producers. That's because we want to be able to say that it is possible to produce maple syrup with high quality, even if we use defoamers in our process. So that's why we went that way. And then the third objective, of course, is to determine the concentration of defoamer residue in maple syrup with our analytical method. We're not there yet. We're not there yet with the residues, but today I'm going to present the theoretical quantity added in maple syrup. You'll see later on what I mean. We had to identify the most commonly used defoamers, and to do so, we consult with equipment manufacturers and producers association in each participating states, and we ended up with 5 types of defoamers. Conventional, like Catherine said earlier, there's the powder defoamer, Aldo HMS, and the liquid defoamer, the Atmos 300K, and of course our organic vegetable oils, sunflower, canola, and Trans 580. The field monitoring was done during 2025 harvesting season with the producers who implement good manufacturing practices, like I said. For everyone, we recorded the volume of defoamer used during syrup production, the volume of syrup produced also, and we collected samples from those production sites, and we recorded, and all the records were made each day that sap was boiled. All the data were used to estimate defoamer residue by calculation, and those calculations helped us to select samples with no, moderate, and high level of defoamer for the analysis of the residues. So a total of 13 production sites were monitored, 4 in Maine, and 5 in New York, and 5 in Vermont. I'm repeating myself here, but from each site, we gathered the type of defoamer used, the processing dates, the total defoamer used per day in grams, total syrup produced per day in gallon, and those data helped us to calculate the average concentration of defoamer in maple syrup per day in ppm. And like I said, samples were collected, and we selected 3 samples for analysis. The monitoring was conducted from March to April, with variation, of course, in production periods among production. This is the field monitoring in Maine, just to give you an idea of what we have what information we have. We monitored 4 production sites in Maine, and as you can see, we had production operation of different sizes, as you can see here in the number of taps. All the sites were working with vacuum and the concentration of sap, and the defoamer used were those here. As you can see, you have the Atmos 300K, Aldo HMS, and organic canola oil. And all these defoamers were added manually or with cups sometimes. In New York, we monitored 5 production sites. And again, we have facilities with different sizes, as you can see here by the number of taps. They were all using vacuums and the concentration of sap. The defoamer used was Aldo HMS, Atmos 300K, and organic sunflowers. And again, defoamer was added manually or sometime with cups also. In Vermont, a total of 5 production sites were monitored. Until today, we have data from 3 production sites. We're still working on the 2 others. But just to let you know that all of the 3 operation sites were using organic oil. They were all organic. And interesting things, they were all using electric pump or drippers to add the defoamer in the evaporator. So just to give you an idea of what is a ppm, I said the concentration was calculated in ppm. But what is a ppm? Just to give you an idea. It's ppm, it's the unit used to express concentration. ppm is the meaning of ppm is parts per million. Also, you can say it is 1 milligram per kilogram of a solution. Just to give you an idea of what it means is you can also say it is 1 grain of sand out of a million. So 1 ppm is very small. So just to give you an idea, some authorized level of food additive, in certain food additive, the level of food additive in certain food area is only 10 ppm. So that's really, really not a lot. I'm not saying here that we have to target with defoamers the 10 ppm, but in other food area, food additive can be as low as 10 ppm. So we'll gather the results and we'll let the government agencies decide what they want. But this is important to understand here. So 10 ppm, for example, is the same thing as if you add 1 pouch of sugar in 100 gallons of sap, for example. That's really, really not a lot. Or if you add 1 teaspoon of liquid defoamer in the same amount of sap. So that it's really, really not a lot. So we have made theoretical concentration calculation in maple syrup. So I'm going to show you the calculation tonight, just to give you an idea of what we can think is added in the product. But at the end, it's the analytical method that will help us to measure the real defoamer residue in the finished product. Now we're getting deeper into the results. This is the example of one producer in Vermont. The way to understand this diagram is that in the y-axis here, you have the defoamer concentration in ppm that was added during the process of the producers was using trans 0580. And this is every day during all the season. As you can see here, the amount of calculated defoamer use is very, very high. I just put here a red line to show, because I wasn't able to draw the line at 10 ppm, which is very, very, very low. But just to give you an idea of the quantity we are adding into our maple syrup here. So this producer is using a lot of defoamer to control the foaming. Now I'm going to show you a mapping of all the producers that we were following during the season. You have the 3 states here. On top, you have the Maine, you have New York, and you have Vermont here at the bottom. The first thing we can see is that there's a smiley shape on the diagrams, showing that sometime at the beginning of the season, you will need higher amount of defoamers, and of course at the end of the season, because the sap is more degraded, you will need much more defoamer to control foaming. So that's in general, you see the smiley shape all the time. But one other thing that is interesting to see is that when you look at, for example, here in Maine, when you use conventional defoamer as compared to organic defoamer, of course, and you already know that conventional defoamers are working better than vegetable oil, of course. So you need to put much less conventional defoamer in the production. You see that here with at most 300K Aldo HMS as compared to canola oil. And it is the same thing in New York and in Vermont, as you can see here. The sunflower oil, you will need to put more sunflower oil or vegetable organic oil to control foaming. And this is because vegetable oil is vegetable oil. It's not, so to speak, a defoamer product. It will do the job, but you will need to put more to control the foaming. Atmos 300K and Aldo HMS are not defoamers, so to speak, also, but they are used in different kind of food processing as emulsifying product to stabilize emulsion. They do the job, and you need to control foaming, but you have to put much less than organic oil. Another thing interesting here is in Vermont. You remember that I said that here I forgot that circle here. It's even if you use conventional product, a defoamer, sometimes the foaming is so important. And at the end of the season, you see that at the end of the season, it's so important that you will need to put way more defoamer in your evaporator, as you can see here. Sometimes that happened. And here, as you remember, in Vermont, the defoamer were used not by hand, but using electric pump or drippers. And as you can see, the level of defoamer is quite high. But of course, it's vegetable oils, which are not working that well. But an interesting thing here is with the sunflower oil, this producer was able, even when using electric pump, was able to control his process in a way that the amount of defoamer is not that high as compared to the others. So this is another way to present the same results. And just to give you a more visual way to compare the products, you still have defoamer concentration ppm on the y-axis, and all the producers in the x-axis. As you can see more easily here is that the amount of defoamer used when you use vegetable oil is much higher. As you can see here, you are, like somewhere between 500 and 1,000 ppm when using organic vegetable oils as compared as the conventional defoamers. But like I said, sometimes it's achievable to use organic vegetable oils to produce maple syrup with a low amount of vegetable oil. It's possible. This is an exception. And you already know that conventional works better than organic vegetable oil. As you can see here, you have to put much less of conventional defoamers as compared to organic. There is a significant difference between the two types of defoamers. But now the question is, what about the residues after processing? This is based, like I said, on calculation. But probably you saw that during processing. Sometimes what you put in the evaporator can be lost on the surface of the evaporator, or probably also in the filtration process. But what amount is left in the product? We don't know that yet. So we are very anxious to pursue our analysis to be able to say to the agencies that even if we use quite high amount of defoamer during the process, at the end in the finishing product, is there any residue left? So that's the question we will answer. Probably it will be the next presentation we're going to give you as soon as we have the results. We can still use the best practices for foam control. Here, you have to rinse the collection system thoroughly at the beginning of the season to eliminate as much as possible microorganisms. You should try to use high quality maple sap and process it promptly, like I said earlier. You can try to optimize evaporator operating parameters to when needed to slow down the foaming process. But of course, when you have to use defoamers, you should select a food grade commercial product with strong defoaming properties and minimal risk of flavor development, because you want to use as less as possible. You should request complete product information for any defoamer used. And at the end, you should assess defoamer quality, odor, and taste prior to use it in processing. You should smell the product and taste it. And if the smell or the taste is bad, don't use it. It's gonna give a bad flavor in your maple syrup. So I want to thank all the participating producers to our study. Their work is very, very appreciated. And I want to thank you for your attention, and we'll be at your disposal for any questions. Thank you.
Thank you, Catherine. Thank you, Nathalie. As you have all seen during this presentation, this is a subject near and dear to my heart. So this is really exciting stuff. Before we open it up to other questions, I have one question. So, Natalie, if you had one top recommendation for best practices to make sure that a producer is going to be able to use the least amount of defoamer possible, what is your number one recommendation?
Oh boy, there's so much to do to avoid, but I think the first one is to try to process the sap as as quick as possible and to keep it as cold as possible, because microorganisms growth can degrade the sap so much. And you see that at the end of the season with the warmer temperature, it's affecting the sap a lot, and foaming occurs a lot because of that.
Good advice. So everyone that's in attendance, you can feel free to open up, raise your hand, put a question in the chat box. You can open your mic and ask. Feel free. Okay, we have one question and a lovely comment from Stu. Hi, Stu. Super presentation on an incredibly important topic for our industry. Concerned that our study samples are very small. Study seems to be moving from a small sample producers and working forward to the final residue in the product. Would strongly encourage sampling of many syrups on the retail shelves to get a statistically valid answer. To the question of how big or small is the problem of residue. So the researchers can answer that question probably. Did you consider, or are you considering in future steps possibly doing a retail sample, or will this study really answer the question that Stu is pointing to, getting an idea of how big the problem might be throughout the industry?
Catherine, do you want to?
Yeah, sure, I can do this one. Well, actually, that was a wonderful question because we are currently collecting retail samples.
Aha!
We were very fortunate to be funded for another year of this project, and part of that entails each of the regions collecting 30 samples throughout their region. So, for instance, for New York State, I'm going all around New York State and collecting retail samples from producers, and those producers, I'm trying to keep it as anonymous as possible, where they don't know who I am, and I'm keeping who they are private, so that we can get a good idea of how much residue is in these retail samples. Yep.
Doing the same in Canada also. We had samples from Ontario, from Quebec, and from New Brunswick. And in Quebec, we made sure that we had samples from the market, from the producers, but also from the buyers, because the buyers are mixing syrup, are pulling barrel of syrup together, and we wanted to see, is there any is the amount of residue the same. So we made sure of that. So this is in progress too in Canada.
Awesome. We have another question from Dr. Mike Recklin, and he wants to know whether ultrafiltration of sap can help reduce foaming. Do we have any data on that?
Probably we should have a look into that, because in milk you can ultrafiltrate milk to lower the amount of microorganisms to so probably that will help reduce the amount of
Okay.
of microorganisms and help keeping the sap as long as possible. Yeah.
Sounds like a good subject for the next research study. And Brian is asking, oh, this is a great question. And Natalie, I think this one is right in your wheelhouse. Will there ever be a way to remove defoamer upon accidental overuse or just because it's not pure? I think we've all had those experiences where there is some disaster in your evaporator and there's an overflow. So maybe the whole cup of defoamer goes in, or there's a malfunction with the doser and the whole bottle is in. So is there a way to magically remove that after, put the toothpaste back in the tube?
I think we will have an answer to that question with the amount of residue left in the product at the end, because we saw that there's a lot of defoamer that was used by the producers, a lot, sometime 2,000 ppm, which is a lot, and we saw exactly the same thing in Canada, but we will see with the residue at the end. If we don't see any residue, or if the residues are in a very, very small amount, that's probably because something is removed somewhere. And maybe at the surface of the evaporator, we lose some defoamer. And I suspect that during the filtration process with diatomaceous earths, probably the filtration aids, probably that already removed some defoamers. We'll see with the analysis we will do in the finished product. But probably we already have our answers.
That's
Yeah.
great.
But the problem with that is with maple syrup. In Canada, at least, we can't use any process to remove anything from the maple syrup or from the sap. So that's, when it's done, I think you have to expect that the filtration process will help.
Well, that will be great to find out the answer of whether our normal filtration process removes some of the defoamer that we add. It's certainly something that people have wondered for a really long time. Let's see, I see one more question in the chat from Stu, if I can get back here. Stu says, this will be fun learning experience to take the winning contest syrups and test for them. Oh, Stu, that you're opening up a Pandora's box there. And John Dula wants to know how we can effectively implement these projects. Well, I guess what that remains to be seen once we have the data from the actual studies. And I have one last question before, as we're approaching the 8 o'clock hour here. One last question for both of you. This is a tough one. I'll put you both in the hot seat. Okay. You know everything there is to know about anti-foaming and defoamers in maple syrup production. What method of adding defoamer to the evaporator would you choose if you had to choose, knowing everything you know about defoamers?
Well, I can speak for my part. I worked in the past on a method to control foaming without using any defoamer. I published that in the Maple Digest, and it's simple. It's just Maybe Abby, you can describe it more easily than me, but it's using pipes in the evaporator with the circulating fluid like water, and just because the temperature inside the stainless tube is different, it keep the foam at lower level as possible, and it's working. It's working, but it's not at the. We need to scale up the device, but this is just in case the amount of defoamer is residue is too high for the agencies. We don't know that yet, but maybe they will say to us, oh, that's really high, you should put that in the label because it's too high. So we have an alternative here to develop, but we are not there yet.
Well, that's an excellent answer and gives us something to think about for the future, because really, hey everyone, there is a way out there that is coming that we can control foam without using any kind of additives. And when we publish this presentation on the YouTube site, we'll pop in a link to that paper in the Maple Digest so that people can go straight to it. Catherine, do you have anything to add on your favorite method of adding anti-foams before we let you guys go?
Well, I think I should preface with the fact that I am not as skilled as Natalie is with anti-foaming agents. Her answer is excellent, and definitely surpasses mine. For my knowledge on anti-foam agents and at least my practical experience with it has been, using it in cups versus applying it with the drippers, I guess it's called the auto drips. So with that, really all I have to say is that if you can do it by hand, that would be wonderful. I know it's insanely busy during the maple season, but if it's possible to reduce the amount of defoamer that you're using, that's what we aim for at the Maple program. And yeah, sorry, not as cool as Natalie's, but
Equally as cool in its
I
own
do.
way.
I want
Yeah.
Natalie's method though, for sure, in our sugar house.
Yeah, for sure, for sure. We will have that to look forward in the future. Okay, so before I turn it over to Lindsay for last second housekeeping, I just wanted to pass on that Stu says thanks to all of you, and I thank you. And Jandula is letting us know that they're going to be sharing their insights with their community in Afghanistan. So this is a future generation seminar. So this is a worldwide audience. So thank you again, Natalie and Catherine. We really appreciate it. And we really look forward to hearing the results of the future parts of the project. And we will definitely have you back for that. Thanks, guys. Lindsay, turn it over to you.
Thanks so much, Abby. Don't go too far, Abby, because I'm probably going to turn it back to you here shortly. But Sarah, if you wouldn't mind launching our exit poll, our next webinar will be coming up on Thursday, April 16th. And our speaker is Mark Eiselhart. And Abby, if you wouldn't mind, would you like to tell everyone a little bit about what Mark is going to be presenting on?
Well, Mark is going to be sort of picking up on some of the same themes that we have talked about tonight. He is going to be giving some best practices for syrup quality, especially in the sugar house. So he'll be talking about some aspects of grading, some aspects of flavor. And with Mark, there will always be something new and interesting that I don't expect and don't anticipate. So I'm very excited to tune into that too. So looking forward to it. And in the meantime, for those of you that are still in the midst of your seasons, I hope you've learned something tonight that might help your production practices. But regardless, have a great rest of your season, and we'll see you in April. Tax day.
Well, thank you, Catherine. Thank you, Natalie. And thank you, Abby, for being here. Thank you, Sarah, for helping us out with the tech. We hope to see everyone here again next month. And if you are local to us here in either Pendleton County, West Virginia, or Highland County, Virginia, happening this weekend are two really awesome maple festivals. So we can encourage you to get out and about this weekend and check out the Highland County Maple Festival or the Mountain State Maple Days.
And if you are in this region, you can hang out with your favorite future generation employee at either McCoy Mill and learn about sycamore research, or which is in Franklin, West Virginia, or in Highland, there's a group of us that will be rotating shifts in our mobile sugar shack at the Highland County Public Schools.
Yeah, so lots of fun maple activities happening right now. 'Tis the season, so wishing everyone the best tree syrup season you can have, and hopefully we will see you here again next month, April 16th at 7 p.m. So thank you, everyone, and have a great rest of your evening.
Thanks, everyone. Good night.
Thank you.
Thanks.